When light enters a lens at a specific angle, it does not bend. Now, lenses are devices which use refraction to change the paths of light rays in order to form images. A convex lens like this one will cause light rays to converge, and a concave lens like this one will cause them to diverge. However, with both of these lenses, if we send rays into the middle of the lens in a specific direction, like so, we see that the direction of the ray doesn't change. Remember that refraction occurs when waves transmit at an angle rather than along the normal. But here, the rays are entering and exiting the lens along their normals. This means that refraction isn't occurring as the rays transmit into and out of the lens. The principal axis of a lens is the line along which a light ray will not have its path changed by the lens. So these two lines are the principal axes of these lenses. In an exam, they will usually be drawn for you, but we can determine where they are as they go through the middle of the lens and make a right angle with the lens's line of symmetry. The principal axis is very important for understanding how the lens works in general. Let's see how by looking at the convex lens more closely. Convex lenses can converge parallel light rays to a point. Let's imagine we have a convex lens and a set of rays parallel to each other. We'll also assume they are parallel to the principal axis. Each ray will undergo refraction as it both enters and exits the lens, like so. Refraction causes the paths of the rays to change, dependent on the angle they made with the normal at a boundary. The lens is shaped in a specific way so that the normals at these boundaries mean that the rays will all pass through the same point here. Any other rays parallel to these will also converge here. This point has a special name. The principal focus of a convex lens is the point where the rays parallel to the principal axis converge after refracting in the lens. So for this lens, this is our principal focus, as the rays parallel to the principal axis converge here. Also notice that this point is on the principal axis. This makes sense, as a ray travelling along the principal axis, which remember will not refract, must also pass through this point. But how does this work for a concave lens? Does that also have a focus? Well, concave lenses have a focus on the same side as the incoming rays. This works differently to the convex lens, so let's take a closer look at how these parallel rays would behave at the lens. This time, the lens is designed so that these rays will refract in a way so that they all spread apart, like so. So it looks like there wouldn't be a focus, as the rays won't converge. Also, what's so special about the shape of this lens if all it does is make the rays spread apart? Well, let's imagine we trace these new rays back through the lens, like so. Then we see that they all meet at a point on the same side of the lens as these incoming rays. Again, any rays parallel to these would follow the same pattern. So this point is a focus, but not the same kind of focus we saw before. The virtual focus of a concave lens is the point where the rays parallel to the principal axis appear to converge after refracting in the lens. So this point here is the virtual focus on the lens. We call this a virtual focus rather than a principal focus, since the rays aren't really converging here. They only appear to if we trace the refracted rays back. Again, we can see that the focus is located on the lens's principal axis. A ray travelling along the axis wouldn't refract, and so it could still be traced back to this point. But do we always need to use light rays to show where the focus is? The focal length of a lens is the distance between the lens's centre and the principal or virtual focus. The focal length is a property only of the lens itself, not the rays we're sending at it. So only things like the material and the curvature of the lens determine it, though this length will always be given to you in an exam. Or you may have to measure it using a ray diagram or a given location for the focus. Let's go back to our two example lenses, with their focuses marked. If we measure the distance from the centre of each lens to its focus, then this would be the focal length. But if we want to use a focal length to locate a focus, how do we know which side of the lens to measure from? Well, the answer is, it doesn't matter. If we measure the same distance on the other side of the convex lens, then we find a second focus. We can do the same for the concave lens. This is because the lenses are symmetrical. So it doesn't matter which side of the lens we direct light rays at. They'll always have a focus to converge or appear to converge to. For your exam, you should be able to define what a focus is and remember that a convex lens has two principal focuses, as the rays will always converge on the opposite side of a lens. And in a concave lens, there are two virtual focuses, as the rays only appear to converge on the same side of the lens.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!